We have all been there, right? You're staring at that little spinning wheel of death, just waiting and waiting. You're trying to stream a movie, hop on a video call, and everything just stops. Well, in this explainer, we're going to pull back the curtain and figure out what's really slowing down your network. So here's our game plan. We'll start with the big question. Why is my network so slow? Then we're going to clear up a huge misconception about bandwidth versus speed. After that, we'll look at the traffic, what's clogging up the digital highway. Then we'll get into the pesky delays that act like a digital drag. And finally, we'll put all the pieces of this performance puzzle together. All right, let's kick things off at the one problem that probably brought you here in the first place.
Ah, yes. This question, the one we've all muttered or, let's be honest, probably shouted at our screens. It feels like it should have a simple answer, but it's actually a really fascinating mix of different factors. And today, we're going to break them all down.
Okay, to really get to the bottom of this, we have to tackle one of the most misunderstood ideas in all of networking, and that's bandwidth.
So what in the world is bandwidth? Well, the simple definition is it's how much data you can send and receive in a specific amount of time. And we measure this in bits per second, or BPS.
Now listen up, because this is the part almost everybody gets wrong. Bandwidth is not speed. It has nothing to do with how fast your data travels from A to B. It's all about how much data can travel down that path at the exact same time.
You know what? Here's the perfect way to picture this. Imagine you need to empty a swimming pool. You could use a little drinking straw, or you could use a huge drain pipe. Now, the speed of the water moving through both is the same, right? But which one's going to empty the pool faster? The drain pipe, of course. And that's because it has a much higher bandwidth. It can move way more water, or in our case, data, all at once. Okay, so if bandwidth is the size of our pipe, the next big question is, what's flowing through it? And what happens when that pipe starts to get a little crowded? Let's talk about traffic.
Just think about your own house. You're probably not the only one on the Wi-Fi. When you've got multiple people, multiple devices, all trying to stream, game, and browse at the same time, well, if the pipe isn't big enough for all that data, you get a slowdown. It is literally a traffic jam on the information superhighway.
But it's not just about the traffic. The road itself makes a huge difference. The transmission media, that's the physical stuff, the cables, the wires, even the airwaves that your data travels on, that has a massive impact on performance.
And to build on that, let's look at the most basic split, wired versus wireless. Now, as a general rule, a physical plugged-in wired connection is almost always going to give you higher and more stable bandwidth than a wireless one. And even with wired connections, not all cables are created equal, not even close. The old-school copper cables that are still in a lot of places, well, they just can't hold a candle to modern fiber optic cables. Fiber gives you a way bigger pipe, which means much, much higher bandwidth.
All right, so we've covered the size of the pipe and the traffic going through it. But there's another sneaky piece to this puzzle. It has nothing to do with how much data is being sent, but everything to do with how long that data takes to arrive. Let's talk about delay.
The official term for this is latency, but really, you could just think of it as travel time for your data. It's the time it takes for a little packet of info to get from the sender all the way to the receiver. If you're a gamer, you probably know this better as ping.
Now that journey isn't always a straight shot. Latency is often caused by bottlenecks, maybe an old piece of hardware, like a router that just can't keep up. These things act like little traffic lights on the data highway, forcing your information to stop and wait before it can continue on its way.
And here's another really sneaky source of delay: errors. Sometimes, as data is flying across the network, it gets a little scrambled. It gets corrupted. When that happens, the system has to go, whoops, that wasn't right, and resend the data. And every single time that has to happen, it adds more delay. So what causes these errors? Well, for a wireless connection, it could be anything from how far you are from the router to physical walls getting in the way. For copper cables, it could be the quality of the cable itself, interference from other electronics, or even just how long the cable is. So, we've looked at bandwidth, we've looked at traffic, and we've looked at all these different kinds of delay. Now, let's step back and see how all these pieces fit together to create the big picture. I think the most important thing to take away from all this is that there's almost never just one single bad guy. Real network performance is a combination of all these things working together, or against each other. For example, you could have a gigantic bandwidth pipe, but if your latency is super high, online gaming is still going to feel awful. That's why high bandwidth is king for streaming a 4K movie, but low latency is everything for competitive gaming. So let's do a quick final recap. You've got bandwidth, which is your pipe size, the number of users, that's all the traffic, the transmission media, that's the quality of the road your data is driving on, the error rate, all the corrected mistakes along the way, and finally, latency, the total travel time for the whole journey.
And that's pretty much it. You're now armed with the knowledge of what actually determines network performance. So, I'll leave you with this question to think about. When you look at your own setup, at home or at work, what do you think is the biggest bottleneck that's holding your network back? Thanks for tuning in.